Hi and welcome to this Java introductory course where we are going to break down programming into simple stories and animations, which will help you understand the concepts better. For you to get maximum out of this course, I shall recommend to try out the exercises at the end of each module. I shall assume that you have Java installed in your system. If not, I will leave a link in the description. Go ahead and check that out. We are also going to use an IDE. You can use your favorite one. I am going to use Eclipse. I will leave a link for downloading the latest stable version of Eclipse in the description. Hope we are done with the installations. Before we begin coding, let us understand what Java is and how it works. To start with the very basics, computers understand zeros and ones only, and we humans use a fairly complex language which computers won't recognize. Here comes an intermediate language which helps humans interact with the machines and specify tasks. This is called a programming language. Java is one such programming language. To be specific, Java is an object-oriented programming language. Simply, everything around you that you see can be classified as an object with certain attributes and behaviors. Let's say a laptop, for example, can be objectified with attributes like brand, price, RAM, and processor, many more, and behaviors like boot up, shut down, install a program, and so on. So as a programmer, we are going to define a blueprint for an object, for a laptop object, specifying the attributes that it contains and defining the behavior it has. The blueprint will be the laptop class, and when a program needs an object of this laptop, they're going to use this class to do so. So without further ado, let's start with the actual hello world code in Java. Here we have Eclipse and we have this welcome message. We don't need it. We are going to create a new project, a Java project. Give it a name, say new project, and choose the execution environment, and everything will be done. I think I don't need to make any changes here, and just click finish. We will have a project ready for us. Eclipse will have this standard defined project structure that it will create for you with all the libraries. Now in the SRC, do a right click, create a new class, name it hello world. Click finish. So we have the hello world being created inside the new project package. To create a main method, and then we are going to print a message saying hello world. As simple as that. Now remember, if these keywords are new to you, this is a language which acts as an intermediary between humans and machines. So this may be new for you, but after all, this is a language which you need to learn, and all the keywords mean something, and this is a pretty simple code. Everything will seem quite familiar within a while. We're going to execute the code as a Java program, and there we go. We have hello world printed in the console. Now to understand how Java is actually compiling the code and producing this output hello world, we need to take a look at this simple diagram. The code that we are writing, the hello world .java in the Eclipse, is basically fed into a Java compiler which converts it into bytecode. This bytecode is understood by Java only, or to be specific, by the JVM only. This bytecode is a file with a .class extension. Say for example, if you're writing a hello world.java, it gets compiled into hello world.class, which contains the bytecode for the program that you just wrote. Now this bytecode is fed into a JVM, which is responsible for interpreting it to a native machine code, which is understood by the machines directly. So why adding this extra layer of conversion? Why we did not convert the source code directly to the machine level code? This is what makes Java machine independent. The bytecode can run on any JVM irrespective of the machines. So Like for Windows, we have a JVM, we have a JVM for Linux, we have a JVM for Mac and Ubuntu, and so on. Once you compile your code in your Windows machine and you create the .class file, say the hello world.class, which is responsible for printing hello world in the console, and you send it to your friend via mail and say that, hey, try to execute this code on your Linux machine, and he tries to execute that hello world.class using his JVM in this Linux, it will work. It will run as smooth as it did here on Windows. First, the Java code gets compiled to the bytecode and then it gets interpreted to native machine code by the JVM. Now that we understand how the JVM compiles and then interprets the Java codes, let us come back to our Hello World code and try and understand the keywords that we have used. To start with, we are going to create another class which is more familiar to us, the laptop class. In this laptop class, we are going to add an attribute, say the brand name. And along with this attribute, we are also going to add a method which is show brand, which is going to return the brand name. Or rather, we can print the brand name directly in the console. Now we have created a simple laptop class with a single attribute called a brand name and a single behavior called showBrand or a method. This public void showBrand is called a method, and this does not take any parameter as input and returns nothing, which is why I've used the void keyword. Same in the hello world, we have also used the void keyword in the main method to signify that this method returns nothing. Now, instead of printing the hello world, we are going to create an object of the laptop class and use its attributes and behaviors to do some task. Let us see how. To create the object, we are going to use the new keyword. Using the object of the laptop class, we are going to call the showBrand method, which should show us the brand of this laptop. But wait, it shows null. This means that the brand name has not been specified. Why so? Because we haven't specified any brand name for this object that we have created. So by default, Java assigns null value to a string which is not been defined. We are going to specify a brand name for this laptop, say Lenovo, like the one I'm using right now. Don't forget to add a semicolon at the end of each statement. This marks the termination of a single statement. Now you can see the brand name has been added for this laptop object and the brand says Lenovo. What we did here is use a feature of the laptop class which has been defined in a separate class within the same package new project, and we have created an object of this laptop class to use the showBrand method, and we have specified a value for the brand name attribute. As we have created a public method in the laptop class, if we had created something called a private method which says show something private, let's say so private, and just printing here something which is private to this class only, and this method can be accessed within this class only. Since this is not a public method, rather we have specified that this is a private method. So if we try to go back to our hello world class and access the private method, say show, you can see it does not uh, show us the show private method. Even if we write show private, it will not be able to find the show private method, because it asks you to change the visibility of show private to package, which will make the show private method public. Now we know what is the function of this public keyword. This is nothing but an access specifier. Now, like private, we have protected and default keywords as well. You can see the scopes in the table below, and we'll come back explaining each of these access specifiers later. Do remember that for a Java code to execute, one must have a main method in the class. Otherwise, it will not show any output. Whenever we execute a Java program, the JVM actually calls this main method, which is why this main method has to be of a very specific syntax, and we do not have the freedom to change this syntax or the specifiers that are given. It has to be public since JVM is going to access it from a separate package. It has to be static because JVM is not going to create an object to access this main method. It is going to access it directly using the class name. Let us demonstrate the functionality of this static method by using a static method here in our laptop class. Say along with brand name, we have something called a RAM in the laptop, and for this RAM we have created a public method, or rather a public static method called showRAM, which is going to print the RAM in the console. I forgot to mention the return type, which is why it was showing me an error, and now it still shows me an error saying that cannot make static reference to a non-static field RAM, and this is correct. This field is not a static field, but it is being accessed from a static block. This is not possible, so you'll have to make this static as well. Now the error is resolved. We get back to the hello world class, and we have created an object and have called the show brand name as of now. Along with this, we are going to call the showRAM. For this, we don't need any object of laptop class. Laptop dot, you can see I can specify the RAM, say 4 GB, and I can also use the show RAM to display the RAM of size 4. For clarity, let me remove this object that we have created in the hello world program, and you can still see we can access the showRAM method without the object of the laptop class. Now you know the functionality of this static keyword. And main is a method name. By convention, you can use any method name in the methods that you mention, but since, like I said, for a Java program to execute, JVM is going to call this main method, this name cannot be changed. This is not a keyword, but you cannot change the name of the main method, as well as the argument parameters. Whenever you are executing a Java code, these are the arguments that are being passed in the command line. I will show the command line execution in later videos for more clarity. I think that is enough for a day, and we can conclude with these keynotes. So first is, why is object-oriented programming language so popular? And point number 2 is, Java codes are both compiled and interpreted. Justify. Comment below your thoughts on these questions and the best comment will be selected and mentioned in the next video. See ya. Bye bye.